Hello, my name is Nicholas and welcome to another Swarm update video. What I've been working on recently is modeling hardware limitations in our scoutBots. If we head over to our simulation, we should see that things look pretty much the same as they did last time, but there's new features and functions happening in the background which I'll talk about. To model hardware limitations, every robot has a flag state which signifies whether that robot is currently functioning or damaged. When a robot is damaged, it cannot perform any actions, it cannot move, it cannot communicate. It basically just sits there and becomes an inanimate object. How this can happen is either by the user clicking on a robot and pressing the delete key to damage that robot, or, more likely, through the robot's internal timer. So as time in the simulation passes, the robot has an internal timer which is randomized between a minute and 3 minutes time. When that timer runs out, the robot will become damaged as if through wear and tear. When robots become damaged, they need to be pushed back to the shuttle by other robots, and the shuttle will then repair them and they will return to a normal functioning state. Any robot can be damaged by this process, and it all basically has the same effect on the robot stops functioning. Damaged robots are identified by the scoutBot network in a similar way to how rocks are identified. And then movement robots need to push those damaged robots back towards the central shuttle, again in a similar way to how rocks are retrieved. So to demonstrate the functionality of the user being able to damage robots, I will have my select key, I will click on robot and I will push the delete key, and this purple outline signifies that this robot is now damaged. What this means is that this robot cannot complete any tasks. It's not interested, it can't communicate, it can't move around, it's non-functional, and it needs to be retrieved by another robot before it can start helping the swarm again. So I've created two robots here. They'll start pushing that robot back towards the shuttle. When it gets there, that robot will then light up again and be repaired and be functional. Its internal damage timer will also be reset, so in a minute to 3 minutes time that robot will again become damaged and repeat. Another thing that's also been added is the ability to, once a bot has been damaged, to press delete again to actually remove that bot from the simulation entirely. What this means is if you get too many robots in the simulation and it starts lagging out, or you want to remove certain types of robots, you can go ahead and do that. In order to implement the hardware limitations and the bot retrieval and repair, very little significant changes had to be made to the codebase. The bot class was given a flag to indicate whether the bot was damaged or not, and given an internal timer, and a little bit of logic to maintain that timer and to change that flag whenever that timer ran out, or whenever the user interacted with that robot in order to make it damaged, or when the shuttle interacted with it to repair it. Apart from those minor changes to how the robots work internally, in order to get the scout robots to identify damaged robots, it was simply adding an extra condition to the same function that identifies rocks that need to be retrieved. And that was literally it. So once a damaged robot has been identified in exactly the same way as how a rock's identified, movement robots will then pick up that push request in the same way and retrieve that object in the same way. The scoutBots are even able to track the damaged robots across their vision field in the same way that they could track the rocks. Now I'm going to talk a little bit about the behavior of the swarm as a whole now that we've got this new damage functionality included. There are two main sort of things that I've noticed. The first one which I'll talk about is the possibility for the entire swarm to shut down, so to speak. And how this happens is that robots become damaged in such a way that there's no scout robots left in order to identify tasks that need to be done, to then delegate that to movement robots. So if all the scouts die, there's no way that new information and new orders can be spread to the workers. In a similar way, if all the workers die, there's no one to actually go and retrieve the damaged robots and make sure that they're repaired and functioning. So if all the workers die, nothing actually gets done, and everyone eventually just damages out and runs out, just dies as well. In order to counter this, theoretically you could allow the shuttle to act as a scout bot as well, meaning that the shuttle can identify tasks within a small radius around it and can delegate those tasks to the movement robots. That way you would at least be guaranteed of the shuttle being in range of one or more scout bot, which means that there will always be at least one scout bot functioning as long as there's movement robots to keep it repaired. There is, however, no way that I can see to easily make sure that running out of movement robots isn't an issue. The second interesting behavior I've noticed is that bots and groups of bots can become isolated very easily. How this usually happens is robots near the outside of the network will run out of power, and then because they are so far outside the center of the network, other robots will never get around to retrieving them because there will always be closer tasks that they can complete. What can also happen is that if robots right on the edge of the network fail and die, and robots in the next layer in also do that, then those furthest out robots can actually become isolated from the network entirely when the resources that are slightly closer to the shuttle get pulled back to the shuttle to be repaired, and that connection between the damaged robot group and the shuttle is broken. The third behavior is sort of caused by this. What I've noticed is that with our network, we'll usually end up having a sort of a shell of dead and damaged robots around the outside of the network, which sort of indicates the functional extent that the network has, meaning that the robots on the outside of the network are consistently damaged and consistently dying, and because they're so far out, if there's not enough movement robots, if there's not enough manpower, if there aren't enough workers to make sure that all of the robots in the network can be repaired and retrieved, then the robots furthest out will start dying and not being repaired simply because there isn't the manpower to go and repair them. And so this means that given any number of movement robots, the swarm can only grow to so big before it starts losing members on the outer rim. So that's about it for this update, and for the project as a whole. I don't plan on including any further features or building in any further functionality to this simulation, so we are basically at the end of this project's lifecycle. I hope you guys have enjoyed this series, seeing my development approach and how the simulation has evolved, and I hope you found it educational or at least entertaining. Once again, if you have any questions or comments or suggestions about the simulation or any part of it, feel free to leave them in the comment section down below. If you've enjoyed this video, give it a like, and if you want to see other videos like it or keep up to date with further videos that I make, check out my channel, there's plenty of stuff there. Pretty soon I'll be uploading an overview video of this project, talking about what I was planning to build, what I ended up building, going through the final solution and talking about how it works and a lot of the components and strategies used to make it. And then that'll be it for this project. So, I hope you guys have enjoyed this video. I'll see you all next time.